Okay, so we will solve this problem. The goal is to replace those two distributed loads by only one couple. So we will have the beam and we will have one couple, and we know this couple, it's minus 8 kilonewton time meter. Okay, so we want to replace those two distributed loads by one couple. Okay, that's called equivalent system. Here we go. So what we know from the beam, we can find the expression of the force FR1. So we'll use the top triangle for the 1 and the lower triangle for the 2. So everything in green is for the upper triangle and everything in blue is for the lower rectangle. So let's speak about FR1. I would call this one FR1. How much is FR1? I would use Y axis, so just negative and the plus counterclockwise. Okay, so FR1 is the maximum force times the length of the triangle, that is B, divided by 2. So this is equal to 3 times B. For the FR2, oops, this is the FR2. Oh, and that's a minus for the top one. So minus 3B, sorry, going down. So for FR2, the magnitude of FR2 is 2 times the total length, and the total length is from A to like all the lengths from A to B. So A plus B. Okay. And what we know is that we want to replace these forces by an if you look at the equivalent system there, FR is equal to 0. We just have a couple. We don't have any resultant forces. So FR1, FR is equal to 0. That means that FR1 plus FR2 is equal to 0. So we can write down minus 3B is equal to 2 times A plus B, plus equals 0. So we got minus 3B plus 2A plus 2B is equal to 0. So we have 2A minus B equal to 0. Or we can write that 2A equal B. We will use that a little bit later. Okay, so that's come from FR1. From FR, the equation for FR. The second equation that we have is the two couple are equivalent. Okay, and let's use a strategic point. Let's use the strategic point B there. Okay, because it doesn't matter which point do we take for the equivalent system with just the couple. The couple is a free vector. We can scoot the couple anywhere. So on the right, the moment about B, it's just like the minus 8 kilonewton time meter. It's just like it's just a couple. It doesn't depend of the point, so that will be the same value everywhere. So now let's work on the left side. On the left side, let me write it there. From B, the distance from B of the force FR1 is 1/3 of the distance, the total length of the triangle, so 1/3 of B. For FR2, the distance is half of the total length of the rectangle. So this distance there is A plus B divided by 2. This one there. Okay. So when we do the equations of the moment of the force FR1 about B plus the moment of FR2 about B, it's equal to the moment about B of the system number 2. So this one is for the system number 2, this one is for system number 1. We have on this side plus FR1 times 1/3 of B, and minus, because this one goes in the negative directions and this one goes in the positive direction. So minus FR2 times A plus B divided by 2, and everything is equal to -8. Okay, so we have FR1 that is 3B. We don't take into account the minus because that's the rotation that is important, and the rotation of is positive direction. So the rotation of FR1 about the point B is counterclockwise, positive directions. So 3B times 1/3 of B minus FR2, that is 2 times A plus B, times the distance A plus B divided by 2, it's equal to -8. Okay, so this one gives us just B, and this one gives us minus just A plus B square, it's equal to -8. So we have B minus A square minus 2AB minus B square equal -8. Oh, I forgot the square there. Sorry, B square. So B square minus B square, ups, ups. So we ended up having minus A square minus 2AB is equal to -8. Okay, we can put plus, plus, plus. Let's use the 2A equal B and put it in this equation. So we get A square plus 2A times B, that is 2A, equal 8. So we got A square plus 4A square, that is equal to 8. We have 5A square, that is equal to 8. A square is equal to 8 divided by 5. And we have A equals square root of 8 divided by 5. Okay, square root of 8 divided by 5, that's 8. So, oops, let me come back there. We got A equal, use a calculator to find this one, and that's 1.26 meter. And now we use the fact that 2A equal B, so B is equal to 2 times A. So B equal 2 times 1.26. So that gives us B equal 2.52 meter. Here we go. We got A equal 1.26 and B equal 2.52. So let's come back on the step that we did. We make the two equivalent system for the external loads, and we solve the first equations, the FR1 plus FR2 equals 0 because the FR equals 0, and the second equations, then the moments done by each distributed load, FR1 and FR2, are equal to the total, the overall couple, that is -8 kilonewton time meter. Okay. This FR1 plus FR2 equals 0 is because we don't want to have any equivalent resultant forces on the equivalent system. So that's it. Let me highlight the two final answer. Bye-bye.